So next up, we're going to have Nadine Nehme. She's a Chief Science Officer for Medicus, and she'll be speaking with us on the way forward for artificial intelligence. One of the things we've seen this morning quite a lot is that the ideas and the innovation that we're all counting on really is forwarded by the artificial intelligence that we're able to get access to, and the way that AI actually is going to help us perform better in the future. So by connecting data, by turning that data into information, and then turning that information into knowledge, that's going to be our way forward. And a lot of these platforms that you've heard about and that you're seeing really rely on that network, whether it be an HEI type network, whether it be research collected secondary de-identified data from a government agency. That data needs to come together. It needs to be available for a lot of these things to work. So Nadine will be joining us and giving us a little more insight into the way forward with AI. Thank you, Nadine.
Hi, thank you very much for having me. I'm really thrilled to be among you and to tell you how we see actually AI working to our profit in healthcare. The way where we stand right now is that AI is a buzzword used widely. A lot of people use it because it's really very interesting, but at the same time it refers to a lot of things that people are either misunderstanding or abusing. We have three main categories whenever we refer to AI. First of all, it can refer to expert systems. These are usually built by experts in the field, where we rely mostly on a cause-effect relation. So you have an input and gives you an output. You have a causality link between them. We have mimicking. So mimicking usually is whenever you teach a machine or the machine learns a pattern and can apply it. It will apply the same observation in any diagnosis it's making without understanding the logic behind it. And the most widely used category is actually data mining, and people refer more and more to it as machine learning, which is not absolutely correct. The data mining is widely used in healthcare, and it presents a lot of advantages. It's quite easy, it's quite fast, it's cheap when you compare it to other methods, but at the same time it actually presents a lot of risks, some of which are in medicine and in sciences. This is very critical because future may be most of the time different than the past. You all heard nowadays that we used to think cholesterol was the bad cop, and now it's becoming more and more evident that sugar is actually what we should stay away from. It's whatever is widely believed in medical field or sciences becomes widely used and widely abused, which also offers another bias in the amount of data you are analyzing. It can actually sometimes mistake correlation and causation, and these are quite different because a correlation between A and B is not a cause. A does not cause B. It has you need actually a massive amount of data in order to have an adequate learning, and this is not always available. And at the end, the most difficult part is that in the medical field and in the healthcare field, there's always the liability system. We always need to find someone to talk to in order to be sure that the advice is given is actually accurate. So the way we are moving with it forward is we are actually deploying our own strategy whenever it comes to artificial intelligence. We are starting with the most difficult part, and this is the expert systems. The expert system we are building a huge amount of information that is linked to each other by the cause. So what if then this will happen. This is a huge work. It takes a lot of time. It's like you go through a huge amount of data and you just have to type down each and every piece of information and relate a rule to it. Then we are using Bayesian inference for what we call our differential diagnosis engine, and this is more used whenever the relation between a cause and effect depends on a huge amount of data points or inputs that cannot be actually taken into consideration by an expert system. And still, we are using machine learning because it's very interesting and it's very important, but you have to use it knowing the risks and you have to know where to apply it. In our case, for now, we are applying it in the health feed personalization, and it's going to be taken to the second phase quite soon. I would just want to tell you two quick words about our medical reasoning engine. So our work is based on taking a lot of data. These can be any biomarkers you are having analyzed. This can be your profile details. Actually, we are mimicking what goes on in the doctor's head whenever you go to see or visit your doctor with any health problem. We match this input with the knowledge and the guidelines, and in this case, since we are using an expert system, we only take into consideration the medical accurate data that has been approved by doctors and by the guidelines of each and every country. We apply to this the reasoning and the rules that we pulled off from the medical books and the articles, and then we have the output that is delivered to our patient and to our doctors. In this case, these can be insights or these can be further questions that will actually feed back the engine. So, as I just told you, it's really using the expert system to have a real-time reasoning and a real-time interpretation, and all this happens instantly on your device in a very personalized manner. It's only based on the accepted medical knowledge, and where we are applying machine learning is that we are able to adapt the engine and personalize it to each and every user's experience. So it knows what to give each patient, when, and how. We are actually able to transform these types of blood reports and whatever data you are pulling from your wearables into something that is much more attractive and user-friendly, that explains to you your medical records. It gives you insights. It gives you a continuous health and lifestyle coaching. All of this is done in an instant manner, and most importantly, it's highly confidential. So it really the engine sits on your phone and operates from your phone, which means that your data is secure. The second part where we are using the Bayesian inference is what we call a diagnosis engine. In this case, the doctor is usually faced with a huge amount of inputs that he needs to analyze, but the most important point here is that the outcome is never one point. It's never one insight. It's not one diagnosis. It's usually several types of diagnosis that we call differential diagnosis. And our engine, in this case, is capable of taking a huge amount of inputs, such as your lifestyle, your lab results, any signs and symptoms you are presented with. We couple this to your data as a patient, and then we give the doctor a list of differential diagnosis using AI, with a score that tells the doctor that this is more likely to happen than any other diagnosis. The important thing in here is that the doctor is always capable of tracing back our own logic. Because we are using an expert system, so A takes you to B, takes you to C, and the doctor can always go from C to A easily, which does not happen with data mining. So this engine actually is applied whenever we have complicated cases. We have no certainty. We have too many variables that are playing a role in the outcome. And this allows us to give a multiple possible diagnoses with a different probability for each one of them. Now, this is how we are playing it out. We started our first phase. We applied our expert systems for the medical reasoning engine, and this is where we are building our basis, our medical knowledge. We have the machine learning for the personalization of your feed, so any data you will be receiving from the application is highly personalized. And we built and validated our diagnosis engine that I just told you about. The second phase is actually to take our differential diagnosis engine into production. And this is very interesting because then doctors can use it and doctor can rely on it because they can trace back any cause we are giving them. And we are introducing the conversational interface using the expert systems and the machine learning. Phase 3 will open. Actually, the very interesting thing for us is that we would like to apply machine learning on top of expert systems. And this is the important part, because in this case, we will be able to open the investigations gap for researchers. What happens nowadays is that you have a gap between the patient data and the medical data, because the medical data has been built on years and years and years of information, cause, evidence, whatever you like, but these are very rigid. And in time, the guidelines do not change as often as they should. While if you have data and you have massive amounts of data from patients, you can actually have both of them presented to the researchers, both of them presented to the medical field, and then allow them to draw the necessary conclusions, because everything can be taken back to its source. The last thing that we would love to do, and this is like our biggest milestone, is a comprehensive medical machine intelligence that would be applied using all what I've just told you about. So we deployed our first phase. We are actually right now deploying our second phase, and we believe that the most important thing will not happen before 2023. Thank you very much for your attention, and I'll take your questions.
Nadine, thanks a lot for that. And it is definitely a challenge to get the users, the citizens, the persons to take an active part in their health.
Absolutely.
I'm pretty sure we have some questions in the audience.
Thanks for that. That was great.
Thank you.
I just wanted to ask, where do you see most of the data coming from that you would use?
We are actually taking the medical guidelines for each and every country. So for now, we cover the medical guidelines for the US. We cover the EU medical guidelines and any difference that exists between France, UK, and Germany. So we base it on medical books, medical guidelines. We have all the other references aside, like every scientific paper that shows things, but we do not include it for now because we need to get the approval of the medical field on the basis, and then we can build on it.
Sorry, one follow-up. What kind of data sources would you use, not for the engine, but like patient data or medical records? Like what kind of... Sorry, did you hear that?
No,
Okay.
sorry.
What kind of data would you use to feed into the engine? Like patient, what kind of patient data?
So the patient data actually, the engine operates with a minimal input from the user. So we just need the age, the gender, and height and weight, because a lot of the things are actually depending on your physical or fitness level. Then the more you feed the engine, the more results you will get out of it. Like we can take them, your medical history, we can take your biomarkers, like any vital signs that you have. Everything that you can feed the engine will actually give you more accurate results.
All right, thank you so much,
Thank
Nadine.
you.
Really appreciate the time there.
Thank you.